Okay, folks, we're starting. Grab a seat.
So this isn't really a talk, more of a demonstration. I'm expecting people to come up and talk to me afterwards and play around with it rather than me telling you all about it. The background is that we have a ping pong work, and ping pong balls go under the tables, and they're a pain in the backside to collect. So I thought, I know, solve this problem using robotics. Really, I was looking for a problem to solve the robotics, and that one happened to show itself. So I have no idea about robotics really. I'm a programmer, so I didn't know anything about hardware when I started. So it was very, I had to seek help. I've joined the Oracle Hackspace. I asked people what to do, how to do things. I learned how to do 3D printing. Several months later, I've ended up with this. It's the ping pong ball collecting robot for the office. It's almost entirely 3D printed. It's a very early prototype, as you can see by the circuit board hanging off the back. And I'm going to show it to you today. So it's got a camera on the front, the Pi camera, which gives you a live feed. The reason it uses a live feed is because the idea of this is rather than writing some sort of AI to drive around and pick the ping pong balls, I thought it would be much more fun to have people from the internet go to a web page and see a live stream and collect ping pong balls for us, and effectively trying to get free labor. It would take a lot longer to get an AI than it would to get random people to do the work for us. And I might have some sort of scoring system, I don't know. I haven't even got to that stage yet. I'm controlling it using this controller at the moment. So I'll put it down here and maybe, hopefully, pick up some ping pong balls, depending on where they go. So I've got an old Xbox gaming pad here. I wrote a software library to pull the values of it and send them over the wireless network I've got set up. The Raspberry Pi is connected to just connects to a really cheap sort of £5 off eBay wireless adapter. So there's a program running on my laptop which pulls the values off this, sends them over a TCP connection to the robot, and then there's a program on the robot written in Go which interprets those and uses the Go hardware I/O library to actually send the signals. I'm using the micro Pi TX add-on board for the two Caterpillar tracks here. These are really nice. These are from Pololu in Las Vegas. I'd like to get some. I'd like to supply those at home if easily and I can find. The circuit board on the back is for the lifter-on. It's an L293, I think L293D, which is still a bit more power, and the lifter-on takes quite a bit of power to lift. So, where are we? You can just about see here on the bottom right, there are the two prongs. I've got a wide-angle lens on there from eBay. I printed a little hold for that, and that just gives you enough field of view in order to drive the robot successfully. Theoretically, the wireless has just dropped out. At the moment, it's very dependent on the wireless signal. If the wireless signal drops out, then it's not going to work very well. Once you've got the hang of it, it's actually fairly easy, but it does take a while. I use this a huge amount. That's right.
Make it hard for you by cutting off.
So if anyone wants to come up and have a go, they're quite welcome to. And I guess I'll take some questions as well.
So have you thought about gaming it so you could have a countdown timer and you have to pick up so many balls within a certain amount of time? Or?
Yeah, I was thinking of having some sort of leaderboard that people could sort of compete against each other.
You could have ping pong ball snooker as well. You could have different colour balls, and you get a red ball and then a blue ball and a red ball and then a... Yeah. Just for the record, Dan said that's a good idea.
So you can see I can go on the tables, which ordinarily I have to get on my hands and knees and there. Yeah. So the way the control system works is that it sends this thing does most of the control. There's very little logic on the actual pie itself. So I send a forwards command to the robot. The robot gets the forward command and it turns the motors on and moves forwards. If the wireless dies after I send the forwards command, it never gets the stop command after I release my hand from the keypad. So if it just goes crazy and starts mowing people down, that's why. You want to come up and have a go? Come on. And does anyone have any questions? Okay, so forwards, back foot still. Spin one direction, spin right. When it's spinning, try and instantly see whether forwards or backwards movement. Up, down. I'm trying to ping pong ball drive through it. There you go. If anyone wants to come closer and have a look or has any questions, do it now or find me afterwards.
You make a fortune if you can get one of those golf balls. So you actually buy them back.
So one of the problems I had, I was using an SM something, I can't remember the exact chip name, to drive the lifter on with the peaks of about 1.6 amps. So it actually uses a lot of power, even just lifting the arm itself. I had to add the L293D because I needed something that would supply above that. So lifting ping pong balls requires some sort of...
Have you thought about counterbalancing the arm though, so there's less load on it?
Yep. Also, I mean, this was the first idea I had.
Yeah.
So I changed the scoop to some sort of vacuum system. Ping pong ball is probably quite easy to suck down a vacuum tube. This is going to be used by people over the public, members of the public over the internet, and they're almost certainly going to try and do things like set fire to our office. So it's got a great big 5 amp hour LiPo battery. The chances are people are going to do nasty stuff with it, and yeah, removing the lifter arm will prevent that from stalling out and damaging the robot or other things.
Yeah.
Yeah.
Kids have it. Yeah. Does it come with batteries? It's not good. Oh, that's what this one's getting away. There's one there. There you go. I was just thinking that, yeah. Trying to get into the street.
You need a sister robot now that goes around and actually buries the ping pong balls, so you don't have to try and get them before they're buried.
The people in the office can bury the ping pong balls quite well. I was thinking about having the two robots competing against each other. But the problem with that is that people will try and sabotage it. Reverse now. People will try and sabotage each other, and no ping pong balls will actually get picked up. So if I had another robot, I'd have to invent some sort of cooperative play.
Or you could have ping pong balls with a Raspberry Pi inside and they have to roll away from the picker.
Anything to get a Raspberry Pi on.
Yeah.
Should I learn there to control the robot which drops balls?
Or no, a Raspberry Pi controlled fan. So that the other person has to direct the fan to blow the balls away.
So there is going to be a base station. The idea is that this will be autonomous. I won't need to go. Someone won't need to go and charge the battery. So there will be a base station. This basket lifts off. There's going to be some mechanism to drive it into the docking station, charge the battery, empty the ping pong balls, and have them here in the basket of ping pong balls. But what I had considered is, rather than putting them in a basket and taking them back, is just trying to work out where the robot was in the room, and then launch the ping pong balls from the robot into the basket. That might interfere with the ping pong games, but it would be quite a lot of fun.
We did a project at our school where we used 2 motors spinning to launch ping pong balls around the room.
Yeah.
So you can have it, each time a ball is launched, you have to go and collect it.
I was thinking you could use it as a pooper scooper at the back.
Use the tiny laces together.
Raising low the arm of it.
We're all totally engrossed on this.
It gets harder the more you get, because then they're going to bounce out.
Yeah, you go because it's be gentle with it everyone.
And you go for the easiest balls to begin with, don't you?
Much like snooker.
Once again.
One of the things I've not had time to do is to print a new hopper. I need to print a bigger hopper. One of the great things about 3D printing most of this is that you can iterate in the design very easily. You can print out, say, a motor housing. You can separate it from your design, you can print it out, you can test it, you can reprint it. And then once you've got it right, you can just incorporate it into your design. So rather than having to design the whole thing and produce it in one shot, if you just reverse that now, that'll work.
No, he wasn't. Not speaking of cable. No, you don't think so. And you get it to go in without pulling. Well, we've got 3.5 minutes. No pressure. I've got 3.5 minutes.
Try and get it in the other side. So, like I said, I'll be hanging around today if anyone wants to come up and have a play or look at it close up. I think we might have to give up on that one. Okay, that's it.